Alright, in this video I'm going to talk about graphing cotangent. Alright, and tangent, basically, if you remember what we have right here, you have your zero, wherever you have for your phase shift, that's your initial point that you're going to graph, and everything goes to the right and to the left from there. So that's the center of your graph. You're at zero there. You're also at zero at pi and negative pi. And so if we think about that, what's the reciprocal of zero? So I just have zero, and I have that over 1, or 0 over 1. The reciprocal of that would just be 1 over 0, which we cannot have, which is undefined. Okay? And wherever tangent is 0 means cotangent is undefined. So at these zeros, I'm going to have asymptotes for cotangent instead of having it at 0. Whereas in order to get the undefined part right here that we have for tangent, we would have had 1 over 0 for that. So the reciprocal of that is 0 over 1, which just is 0. So we have a couple of things that we already know now based on tangent's graph, what we're going to have for cotangent. So let's look. So if I start at 0, and then I've got pi over 4, pi over 2, 3 pi over 4, and pi. Then I'm going to go to negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. All right, so I've got these things right here. And so let's refer back to the tangent graph again. So tangent at negative pi, 0, and pi was 0. And the reciprocal of 0 is undefined. So I already know right now, based off of that information, that at negative pi, 0, and pi, I'm going to have an asymptote. All right, let's go back over here and look at this again. Okay, and now also, wherever tangent was undefined, wherever that was 1 over 0, the reciprocal of that is 0 over 1, which is just 0. So wherever tangent was an asymptote, and so it was undefined, cotangent is actually going to be 0. Now, am I saying every time you have undefined, the reciprocal is 0? No, I'm saying the reason for that is because the value we had to use to get undefined for tangent was 1 over 0. Okay, so now I've got zeros right there at negative pi over 2 and pi over 2. And then, so from there, now I have to decide what I'm going to do with my graph. Well, it's a reciprocal. It's always going to be the opposite of it. So basically, what you're going to end up doing is you're going to reflect the graph, but you're kind of reflecting it vertically. So here's what I've got. It's going to go up like that right there, and down right here. And again, up there, and then down here, okay? So this is a decreasing function. It's decreasing left to right. It has a negative slope from left to right. So it looks very similar to your negative tangent graph. Difference is just where the asymptotes are and how that's set up. But aside from that, it's the same shape. So just like cosine and sine are the same shape, you're just looking at different portions of the same kind of wave. Tangent and cotangent are similar like that. All right, so hopefully that'll get you squared away with cotangent. So what I've got right here, let's look at this next example and let's actually apply some of this information. So cotangent itself has a period of pi. So we're going to do the same thing where we have pi over b. So in this case, I have pi over 1. So that just gets me just pi is my B is 1. My x-intercepts, sorry, that should have been changed. I forgot to fix the typo before I put it on here. Instead, it should actually be equation for midline. So this is your midline equation. Okay? And in this case, that's always going to be y equals d, and we don't have a d value here, so it's just y equals 0. So it's our x-axis. The vertical asymptote equations, we're going to hold off on doing those just yet. Phase shift. So I have a negative pi over 2 inside here, so that means that my phase shift is positive pi over 2. So I'm shifting to the right pi over 2. All right, so what we're going to do is we're going to go ahead, we're going to draw our x-axis, not exactly straight, but, you know, we'll roll with it. All right, in the center, where I've got right here, that's going to be whatever my phase shift is. So here, this is positive pi over 2. And then I've got to label 4 points to the right and 4 points to the left. Okay? The ending point right here is always going to be the same as whatever I'm starting with, my phase shift plus my period. So that one would be pi over 2 plus pi. So that's going to get me 3 pi over 2. So that's where I'm going to be ending, is at 3 pi over 2. And I'm going to do the same thing, except I'm going to do pi over 2 minus pi. And that's going to get me this value right here. And so when I end up doing that, that's going to get me negative pi over 2. So negative pi over 2. Now, in order to figure out everything in between there, what I'm going to have to do is figure out what my period is and divide that into 4 pieces. So we're going to call that our quarter. So our quarter is pi over 4. That's our period divided into 4 pieces. So that's what I'm going to add each section to get to the next value. So if I start at pi over 2, I'm going to add pi over 4. And then in order to do that, remember you have to have a common denominator. So I'm going to multiply on the left side by 2. And now I have 2 pi plus pi, which is going to get me 3 pi over 4. So that's my next value here, 3 pi over 4. And then again, I'm going to add another pi over 4, which is going to get me 4 pi over 4, which is just pi. Add another, I get 5 pi over 4. And then I'm going to double check and make sure if I add another pi over 4, does it get me 3 pi over 2? Sure enough, it does, because it gets me 6 pi over 4, which is the same when it reduces. And then I'm going to go backwards. I'm going to go the other way. So I'm going to go from pi over 2, and I'm going to subtract pi over 4. So same thing, 2 pi over 2, or 2 pi over 4 minus pi over 4 is going to get me pi over 4 right here. And then I'm going to subtract pi over 4 again, and then now I'm going to get 0. Then I'm going to get negative pi over 4. And then I would get negative 2 pi over 4, which reduces to negative pi over 2. So I've got all of my values right there for my x-axis. I also conveniently have a 0, and whenever I have 0, I now know exactly where my y-axis goes. If you don't have a 0, but you have negative numbers and then positive numbers, well, the y-axis goes right in between those. It's always in between the negative and the positives. You don't have positive numbers to the left of your y-axis, just like you don't have negative numbers to the right of your y-axis. All right, so then now what I'm going to do here is I'm going to go ahead and start graphing. Remember, at the center, so that initial point that we have, it's no longer 0, it's now an asymptote. So I'm going to draw that. I have an asymptote at the phase shift and at the length of my period. So at the beginning and at the end of my 2 periods, do I have an asymptote as well as right smack dab in the middle. all right? Then at the 0 right here, that I have right here, and at pi right here, so right down in the middle of your asymptotes, you have a point on your midline, whatever that happens to be. And in this case, the midline is on our x-axis. And then we're going to draw our graph as a decreasing function. Left to right, it's going down. Now I can write the equations for my vertical asymptotes as well. It's going to be x equals, and then we're going to start with our first positive asymptote. In this case, that's pi over 2. I'm going to plus or minus whatever the length of my period is. And in this case, that's pi n. So it's just like whenever we found the equation for the asymptotes for tangent. It's exactly the same way that we're going to do that, because it's exactly the same, because they both have a period of pi. And then they both are just going to keep cycling those asymptotes every pi. Okay? Or really, I should say, whatever the length of the period is. In this case, it was pi. All right. So let me know if you have any questions.